In this lesson, we'll be looking at the particulate nature of matter. The particulate nature of matter, to summarize that, simply put, is trying to tell us the fact that all matter are made up of particles. So if all matter are made up of particles, the question is, what is a particle? In a layman's term, if you pick up any substance, any material, any object, and you divide that object repeatedly into smaller bits, it will come to a stage whereby you obtain the smallest bit of that object that you cannot divide it further. That smallest bit that cannot be divided further can be seen as a particle of that object. So this topic, talking about particular nature of matter, is trying to let us know that all matter are made up of particles. All matter are made up of tiny pieces. It's the tiny pieces that come together, combine, or interact to form any material, any object, any substance that you can find around you. Now, these particles may be in form of atoms, molecules, or ions, depending on the type of substance in question. Now, it could be an atom if the material or the substance or the object in question is an element. In other words, the smallest particles of elements are atoms. And it could be molecule if the substance in question is either an element or a compound. Then it could be ions if the substance in question is a charged particle. Then the question is, what is an atom, what is a molecule, and what is an ion? Let's start with atom. Atom, the literal meaning is indivisible. It's a Greek word which means indivisible, like something that cannot be divided further. Like I said, that if you pick up any object around you and you divide it continuously, you will eventually get to a stage that you cannot divide the smallest bit of it further. So the Greek were the people that used this word atom to describe the smallest bit or the smallest part of any object. And in the literal meaning or the literal sense of the word atom, it means indivisible, meaning the Greeks see the atom as the smallest part of any object, the smallest part of any material atom was seen to be the atom. And the Greek considered the atom to be indivisible. And so they used the word atom to describe the indivisible part or the smallest particle of any substance. And the actual existence of atom was established in the 19th century by John Dalton, who put forward a theory to describe the nature of atom. So the atom is now considered to be the basic unit of the simple substance or the element, as I said before, that since this topic is about the fact that all matter are made up of particles, now these particles could be atom, could be molecule, could be ion. And then we say that it is atom if the substance in question is an element. So now, atom is what? The smallest or the basic unit of element. And John Dalton was able to put forward a theory called the Dalton atomic theory to describe the atom. By the way, what is an atom? Atom is the smallest particle of an element which can take part in a chemical reaction. The smallest particle of an element that can take part in a chemical reaction is known as the atom. It is the smallest particle that can ever exist alone and still possess the chemical properties of that element. So that includes forward a lot of theory to describe the atom, which we are going to look at shortly. Now we say that the smallest particles of any matter or any substance could be molecule also. And what is a molecule? Most atoms cannot exist independently. And we say that atom is the smallest particle of an element. There are some elements that cannot exist as an atom. That is, they have to combine two or more atoms before they can exist. So when two atoms combine, what you have is a molecule. When two or more atoms combine, it forms a molecule of that element. So most atoms cannot exist alone, so they combine with other atoms to form molecules. The combination may be between the atom of the same element or atoms of different elements. For example, whenever you see the symbol of hydrogen written, you see a number 2 attached to it. The question is, where is this 2 coming from? The 2 is there because hydrogen as an element cannot exist as a single atom. The atom of hydrogen is H, but we do not write the symbol as H, rather we write it as H2 because hydrogen does not exist as a single atom. It must combine with another atom to form a hydrogen molecule. So hydrogen atom plus hydrogen atom is of course two hydrogen atom, which is denoted as H2. So it is this H2 that is capable of existence as hydrogen. And this is a molecule, not an atom. It is atom when it is H. But the moment two of them combine to form H2, is no longer an atom. This H2 is no longer an atom, but what? A molecule of hydrogen. That is why we say that atoms combine either between atom of the same element or atom of different elements. That is what this point is saying, that the combination may be between atom of the same element or atoms of different elements. Also, whenever we write a symbol of chlorine, we usually write it as Cl2. Where is the 2 coming from? Because chlorine also does not exist as a single atom. It combines with another atom to form a molecule of chlorine. The same thing applies to oxygen. All the elements that has a number attached to their symbol. It means they do not exist as a single atom. They combine atoms to form molecules of that element. We also have something like even the polyatomic element like phosphorus, that is P4, and sulfur, that is S8. All of it, like phosphorus now, combine four atoms together to form a molecule of phosphorus before it can exist. Sulfur combine up to 8 atoms to form a molecule of sulfur before it can exist. So in essence, molecules are what? The smallest particles of a substance. Substance here because it could be an element or a compound. This H2 is a molecule of an element because these are the same atom. It's some atom of the same element coming together to form this H2, which is hydrogen molecule. The same thing, this Cl2 is molecule of an element, O2, molecule of an element. But when you have atoms of different elements coming together to form a molecule, then it's no longer a molecule of an element, but a molecule of a compound. For example, you can have sodium atom combining with chlorine atom to give us sodium chloride. So in this case, this is a molecule of a compound. And this molecule of this compound is formed by what? A combination of one atom of sodium and one atom of chlorine to form one molecule of sodium chloride. So the point here is the moment it is atoms of different elements coming together to form a molecule, then the molecule form is a molecule of a compound. That is why the definition says that molecule is what? The smallest substance, or the smallest particles rather, of a substance. Substance could be what? An element, it could be a compound. The smallest what? Particle of a substance, or that is capable of independent existence. So the point is why atom is specifically the smallest particle of an element. Molecule is the smallest particle of either an element or a compound that is capable of independent existence. Thus, so most atoms cannot exist alone, so they combine with other atoms to form molecules. The combination may be between atoms of the same or atoms of different elements. So now because molecules could be molecules of element or molecules of compound, now based on that we have some elements that are monoatomic, we have some other ones that are diatomic, we have some other ones that are triatomic, and you have some other ones that are polyatomic. Because most elements cannot exist as a single atom. So they combine with other atoms to form either diatomic molecules, diatomic molecule, meaning they have two atoms in a molecule. The word di means two. So diatomic molecules means a molecule that contains two atoms. An example is hydrogen. That is why it's always written as H2. The same thing, oxygen, O2, and chlorine, Cl2. All these elements that always have two in front of them, the two means that it's made up of, the molecule is made up of two atoms. And so such an element is called diatomic molecule. And you also have those that are triatomic, like the ozone, O3, that is a special form of oxygen allotropes. Most elements, like metals like sodium, magnesium, aluminum, and iron, and noble gases, can exist as single atom called monatomic element. However, elements like hydrogen, oxygen, chlorine that have atoms in a molecule are called diatomic molecules because they have what, two atoms in a molecule. While elements like ozone that exist as three atoms are triatomic elements, and those that have more than three atoms are polyatomic elements. Examples are sulfur and phosphorus. Now we have a table here showing different elements, the formula of the element, and the atomicity of the element. The first one here is neon. Neon is a noble gas. All noble gases are monoatomic. Monoatomic meaning they can exist as a single atom. And so the atomicity of neon is 1. Then argon is also a noble gas. It can exist as a single atom. Argon, the symbol is Ar. The atomicity is also 1. Hydrogen is a diatomic molecule. Cannot exist as a single atom. It must combine two atoms to exist as a molecule. And the symbol is H2. That means the atomicity is 2. Then nitrogen is also diatomic. It combines two atoms before it can exist as a molecule, and so the atomicity is 2. Oxygen, the same thing, is diatomic. Two atoms must combine before oxygen can exist as a molecule, so the atomicity is 2. Ozone is triatomic. Three atoms of oxygen comes together to form a molecule of an ozone. Therefore, the atomicity is 3. Then phosphorus is polyatomic. Four atoms of phosphorus must come together before phosphorus can exist as an element. And so it's polyatomic. The atomicity is 4. Why sulfur? 8 atoms must come together before sulfur can exist. It's also polyatomic with atomicity of 8. So the point here is atomicity of an element is the number of atoms in one molecule of that element. Okay, so that is it about atoms and molecules. So to recap, atom is the smallest particle of element, specifically element that can exist and still retain the property of that element. While molecule is the smallest particle of a substance. The substance could be an element, could be a compound, but some elements exist as molecules, while others can exist as a single atom. Ions, on the other hand, are charged particles. Some substances are built up of charged particles called ions. Now, there are two types of charges, the positively charged particles and the negatively charged particles. The positively charged ones are called cations, while the negatively charged are called anion. Now, the question is, how do this charge come about? From our previous class, we said that metals ionize by losing electrons. Why not metals ionize by gaining electrons? Now, when an electron is lost from metal, the result of what is formed is a charged particle. For example, when sodium loses an electron, that's because the number of electrons is no longer equal to the number of protons. Sodium in its neutral state is neutral because number of electrons is equal to the number of protons. Recall that electrons are negatively charged while protons are positively charged. And in any atom, the number of electrons is always equal to the number of protons. And so the charge is cancelled out for a neutral atom. But the moment an electron is lost from a metal, for example, sodium, then the number of electrons will no longer be equal to the number of protons. A proton is now more than the number of electrons. That is why we denote that by sodium plus, meaning sodium now is having excess of positive charge because number of proton now is more than number of electron. So this type of thing is called a charged particle. In this case, this is a positively charged particle, which is known as cation. And this happens when metals lose electron. Now, non-metals will usually gain electron. Now, where are they gaining those electrons from? From the ones that are lost from metals. For example, chlorine can accept this electron that is lost from sodium. If the chlorine atom picks it up, and chlorine becomes a charged particle, having more of electron now than proton. That is why it's carrying what? Excess of negative charge. Since electrons are negatively charged. In its neutral state, the number of proton and electron are equal. But now it's gaining an excess electron, an extra electron from sodium. And so now it becomes a charged particle. And this charged particle, because it's negative, is called an anion. So we define an ion as any atom or group of atoms that possess an electric charge. In this case, sodium or all metals, when they lose electron, they become positively charged. Why non-metal gain electron to become negatively charged? Okay, so as I said earlier, that the word atom comes from Greek word which means indivisible. And the Greek used that word indivisible to describe atom of any material, of any object. That is a smallest part that cannot be divided further. Now, in the 19th century, a man called John Dalton put forward theory to describe the property of the atom. And this theory is now known as the Dalton atomic theory. Now, the theory says that all elements are made up of small, indivisible particles called atoms. Now, Dalton's atomic theory has a lot of problems, which we are going to look at as we progress in its modification. So, if you look at the theory we have here on the board, you can see some words are highlighted, size, manner, like this, indivisible. Dalton says that all elements are made up of small, indivisible particles called atoms. Now, the problem with this word or with this theory is the word indivisible, as we are going to see when we come to the modification of his theory. So let's first of all look at the theory, and when we come to the modification, we will see what is the problem with his theory and what is now acceptable as his theory. So let's just look at the theory one by one first. So John Dalton proposed the following atomic theory in the year 1808. The first theory says all elements are what? Made up of small, indivisible particles called atoms. While the second theory says atoms can neither be created nor destroyed. That is, when you carry out a chemical reaction, atoms are neither created nor destroyed. Now, the third theory says atoms of the same element are alike in every aspect, but differ from atoms of all other elements. And then the fourth one says, when atoms combine with other atoms, they do so in simple ratios. While the fifth one says, all chemical changes result from the combination or separation of atoms. Now, Dalton's atomic theory was partially supported by experimental evidences deduced from the law of conservation of mass, the law of definite proportion, the law of multiple proportion, and the likes. However, his theory could not explain electrolysis and certain other phenomena in chemistry. So, as a result of new discovery, his theory has undergone several modifications, but the principal aspects as outlined here still remain and are relevant in the study of chemistry till today. Now, what are the modifications of this theory? Like I said, some of the words he used to describe the atom are not acceptable. Like the first theory said that all elements are made up of small, indivisible particles called atom. The problem with that theory is the word indivisible. Now you say something is indivisible if you cannot split it up to different components. But as we know it today, the atoms is made up of electron and neutron. The question here is if something is made up of three parts or three components, three individual components, then you can separate the component from each other. Can we say that such a thing is indivisible? Certainly not. So that will say that the atom is indivisible. However, now that we know that atom is made up of three subatomic particles, then that theory is not true because the atom is not indivisible. So all elements, yeah, they are made up of atom, but the atom is not indivisible. That is the only thing that about this theory. So this theory was proven wrong by Rutherford discovery. It was Rutherford that discovered that the atom is made up of three subatomic particles, called proton, electron, and neutron. Therefore, that theory is no longer valid. This that thing's atomic theory is not valid in the sense that the atom is not indivisible. Now, his second theory says that atoms can neither be created nor destroyed. Now, this theory holds true for ordinary chemical reactions only. It was proven by the law of conservation of mass, which we are going to look at in our next class. The law of conservation of mass states that during a chemical reaction, matter is neither created nor destroyed. This happens only for ordinary chemical reactions. And when you come to complex chemical reaction like radioactive reaction, atom can be created and it can be destroyed. So this second theory is not completely true. Okay, now the third theory says the atoms of the same element are alike in every aspect, but differ from atoms of all other elements. Yeah, the only problem here is the word alike in every aspect. Atoms of the same element are alike in every aspect. They are not alike in every aspect because of the existence of isotopy. There are some atoms of the same element having the same atomic number but different mass number. Now, it's something that have different mass number. Yeah, even though they are atom of the same element, but their masses are different. And we cannot say that they are alike in every aspect. The masses alone differentiate them. And now the question is, why is it that they have different masses? It is because of different number of proton, different number of neutron. Rather. Recall that the atom is made up of three subatomic particles, and these subatomic particles, the proton and the neutron, are situated within the nucleus of the atom, while the electron revolve around the nucleus in a cloud-like pattern. Now, some element, the number of neutron in atom of the same element can vary sometimes. A good example is an isotope chlorine 35 and isotope chlorine 37. Chlorine 35 and chlorine 37. Now, these 35 and 37 represent their mass number. So, if there is an atom of chlorine that has a mass of 35, and another atom of chlorine has a mass of 37, then we can say that all atoms of chlorine are alike in every aspect according to that. That renders that is theory invalid because these two atoms are not alike in every aspect. Their masses differ, and this difference is because of the number of neutron here is less than the number of neutron here. And this phenomenon is known as isotopy. Isotopy is what? Existence of atoms of the same element having the same atomic number but different mass number. Okay, now the fourth theory is when atoms combine with other atoms, they do so in simple ratio. In simple ratio is the problem here. Simple ratio. Now, this statement is generally true for inorganic compounds, which usually contain a few atoms per molecule. But if you talk about organic compounds that contain several atoms in large molecules, things like protein, carbohydrate, fats, starch can contain thousands of molecules, thousands of atoms in a single molecule. So you cannot say that when they combine, they do so in simple ratio. So while the theory is true for simple inorganic compound, it is not true for complex organic compound. So that is that for Darting theory and the modification of his theory. So as we have it now, we cannot say that atoms are indivisible. That is number one. Darting said that they are indivisible, but now we know that the atom is not indivisible. Also, Darting said that atom can neither be created nor destroyed. That is true for only simple chemical reaction. When you come to nuclear reaction, that is not true. They also say that atoms of the same element are alike in every aspect. That is not true because of the discovery of isotopes. And then he said that atoms combine in simple ratio. That is true only for inorganic compounds that contain few atoms in a molecule. But when you come to organic, that is not true.